now that we've learned what the definition of economic profit is, now we're going to look in this module at how firms maximize profit. So in this module, we'll return to our good friend marginal analysis, because economists always say decisions are made at the margin, and we'll perform marginal analysis to understand how profit is maximized. And then we'll determine the profit maximizing level of output using the optimal output rule. In other words, we'll determine the quantity of a good or service that a firm should produce to maximize its profit. The previous module defined economic profit as the difference between total revenue and total cost. And you see that defined here. Both total revenue and total cost are a function of the quantity of output. As more output is sold, as more output is sold at a constant price, total revenue rises. But so too does total cost. The goal of the firm is simple. Find the level of output where the economic profit is the greatest, or maximized. Now, let's look at an example of this to see how this works. So Eli and Max have a lemonade stand. They can sell as many cups as they want at the market price of $2 per cup. Their goal is simple. Produce the quantity of lemonade that maximizes their profits. So here we see in the first column the number of cups of lemonade they produce, the total revenue. If they're selling lemonade for $2 per cup, then we multiply the number of cups they sell by the price, and that gives us total revenue. We see the total cost to produce each one, and then when you subtract total cost from total revenue, that gives you your profit. Now, as the profit column indicates, profit rises until we get to the 9th cup of lemonade. Let me move that so that we can see this whole screen. So that when we get to the 9th cup of lemonade, you see that profit actually begins to decline at the 9th cup. It's maximized at the 7th and 8th cup with $6 of profit. Now, you might ask, well, why 8 cups? Why would we produce 8 and not 7? Because profit is $6 at both levels of output. Well, in such cases, firms will choose to produce the larger of 2 levels of output. They're indifferent about it. It really doesn't matter to them, so if it's equal at 2 different levels, they'll just produce the larger level, and that's the one that you should go with. So now we have to consider, well, what about their lemonade stand? Okay. And how do they produce profit from it? Well, here's another example. You know, Jennifer and Jason on their wheat farm. Again, if they're producing tomatoes, you can see their total revenue from producing bushels of tomatoes, which they sell for $18 a bushel. You can see the total cost of producing it, and that their profit is maximized by selling 5 bushels of tomatoes, when the profit is $18. That's the greatest amount of profit. But how did we arrive at that? Well, we can use marginal analysis to choose the profit maximizing quantity of an output. Well, how do we do that? Well, to use marginal analysis, the lemonade stand could make their profit maximizing output decision on an incremental or marginal basis. Imagine that Eli and Max ask the following question: should we produce the next cup of lemonade? If the additional dollars coming into the firm as revenue outweigh the additional dollars going out as cost, the answer is yes. So it's always a should we produce the next cup question, or should we produce the next good question. If the answer is yes, if the dollars coming in are greater than the dollars going out, the answer to that question is yes. And as long as it's yes, we should keep producing another good or another cup. When the answer is no, when the dollars going out are greater than the dollars coming in, then we should not produce the next cup. So we produce up until that point. So here are 2 important concepts. Marginal revenue. Marginal revenue is the change in total revenue divided by the change in output. Or we could say it's the change in total revenue generated by 1 additional unit of output. Similarly, marginal cost is the change in total cost divided by the change in output, or the change in total cost generated by 1 additional unit of output. So if output is changing by 1 unit at a time, marginal revenue will just equal the change in total revenue, and marginal cost will just equal the change in total cost. So now let's let's look at this first. There's a rule that we're going to talk about as we look at the lemonade stand, but it's called the optimal output rule. And we'll see that the optimal output rule says that profit is always maximized by producing the quantity of output at which the marginal cost of the last unit produced is equal to the marginal revenue. And this is going to be a very important rule, and it's going to apply to all firms in all types of market structures. Whenever marginal revenue is equal to marginal cost, meaning when the dollars coming in are equal to the dollars going out, that is going to be the point at where profit is going to be greatest. Profit will be maximized. And so we can call this the optimal output rule. Sometimes we call this the profit maximizing rule, where marginal revenue equals marginal cost. So the quantity of output at which marginal revenue equals marginal cost, and I can't stress this enough, this is a rule that you must know. That's the focus of firms, and if you're a wise AP exam taker, you know this rule, because it's the quantity that maximizes profit for firms in every type of market structure, whether it's perfect competition or ones that we're going to look at in a little while, monopoly, oligopoly, and monopolistic competition. The rule is the same in every type of market structure. Let me go back. I went ahead too quickly. Okay, so let's go back to the lemonade stand. And let's convert the lemonade table into a table of marginal dollars coming in and going out. You should see that the total revenue rises by $2 every time we sell another glass of lemonade, every time we produce another unit. So here's something else that's true with perfectly competitive firms. Marginal revenue will be equal to the price. Now that will only be true for perfectly competitive firms. It won't be true for monopolies and other types of market structure. But with a perfectly competitive firm, marginal revenue will always be equal to the price, which in this case is $2. But total cost, notice, does not stay the same. Total cost rises by larger and larger amounts, which implies that marginal cost is rising as more units are produced. Because Eli and Max are making production decisions on an incremental or marginal basis, they will never produce the 9th unit. Because notice what happens. Before you get to the 9th unit, marginal revenue is greater than marginal cost. Marginal revenue is always $2, and if you look at the marginal cost column, you'll see that for every unit we produce, the marginal cost is less than $2, until we get to the 8th cup, where the marginal cost is $2 and the marginal revenue is $2. So the money going out is equal to the money coming in. And it doesn't add anything to our profit. Up until that point, we always add more to our total profit by producing more, because there are more dollars coming in than going out. So the answer to producing that unit is yes. But once we get to the 9th unit, notice $2.25 is going out to produce it, only $2 is coming in. That takes away from our profit, and so we shouldn't produce that unit. So because they're making this decision this way, they will never produce the 9th unit, because the additional dollars coming in as marginal revenue are always outweighed by the additional dollars going out as marginal cost past the 9th unit. So for units 1 through 7, profits are rising because marginal revenue is greater than marginal cost. So these should definitely be produced. For units 9 and 10, profits fall because marginal revenue is less than marginal cost. These units should not be produced. Therefore, production should stop at the 8th unit, where marginal revenue equals marginal cost. And this is the optimal output rule, or the profit maximizing rule, and it's one of the cornerstone results in microeconomics. It's a rule that you must know, and you will see it used in every type of market structure to maximize profit. Here you see it again with Jennifer and Jason's farm. You see their short-run costs, you see their total cost, and you see the quantity that they should produce is 5. Now, you might look at this and say, oh, but marginal cost is never equal to marginal revenue. When we go from 4 to 5 bushels of tomatoes, marginal revenue is 18, marginal cost is 16, so we should produce that. But then when you go from 5 to 6, marginal cost is 20, marginal revenue is 18, we shouldn't produce that. In some examples, marginal revenue will never be equal to marginal cost. So how do you know how many to produce? Well, as long as marginal revenue is greater than marginal cost, you should produce it. But if marginal cost is greater than marginal revenue, you should not produce it. So if they're not equal, produce up until the point where marginal cost becomes greater than marginal revenue. You should not produce that. You should never produce if marginal cost is greater than marginal revenue. So produce up until that point and then stop. That's how you know what is profitable. So the firm's optimal output rule says that a firm's profit is maximized by producing the quantity of output at which the marginal cost of the last unit produced is equal to the market price. And the marginal revenue curve will show us how marginal revenue varies as output varies. So when we graph this, what we see is that because when we sell a bushel of tomatoes, every bushel is sold for $18, marginal revenue will always be $18. So for one unit, if we sell one bushel, it's 18. If we sell two, it's 18. If we sell three, it's 18, and so forth. And that is the price of a bushel of tomatoes. So for a perfectly competitive firm, marginal revenue will always be equal to the price. And it will always be a horizontal curve at the market price. Marginal cost will look like a Nike swoosh, because when we produce the first few units, because of increasing marginal returns, the marginal cost actually declines for the first few units because of specialization and increasing marginal returns in the first few units. But once we get a few units in, diminishing marginal returns will always set in, and marginal cost will begin to rise. Thus, the marginal cost curve looks like a Nike swoosh. And it rises until the point where it crosses the marginal revenue curve. Now notice, if you draw a dashed line down from the point where the marginal cost curve is equal to the marginal revenue curve and they intersect, you'll notice that is the profit maximizing quantity, 5 bushels of tomatoes. Now why is that true? Well, because before that point, notice the marginal cost curve is always underneath the marginal revenue curve, which implies that marginal cost is always less than marginal revenue. Therefore, it's adding to profit and you should produce more. But once it crosses the marginal revenue curve and marginal cost becomes higher than the marginal revenue curve, marginal costs are higher and then subtracting from profit. So you always produce as long as it's adding to profit, but you don't produce if it's subtracting from profit. So what's the profit maximizing point? The point where the marginal cost curve crosses the marginal revenue curve. And that is the profit maximizing quantity of production, where marginal revenue equals marginal cost. So we see it graphically. Now, I've stated this before, but it's stated here again, and you should be aware of this. If there is no output level at which marginal revenue equals marginal cost, the firm should produce the largest quantity at which MR is greater than marginal cost, but never produce when marginal cost is greater than marginal revenue. Now, here's another graph where we can look at it. Assume that every unit can be sold for $10. Which unit maximizes profit? Okay. And you should see there, it's the fourth unit, because at a quantity of 4, that's where marginal cost is equal to marginal revenue. And you should never produce 5 units, because if you produce 5, the marginal cost is 12, so $12 are going out. You're selling it for 10, only 10 is coming in. So more money is going out than coming in, and that subtracts from your profit, so you should not produce the 5th unit. So we've used marginal analysis to find the profit maximizing quantity of output in this graph, which tells us it's 4 units. So when is production profitable? The example above shows that positive economic profits are being enjoyed by the lemonade stand. At the price of $2 per cup, the total revenue of selling 8 cups exceeds the total economic cost of producing those 8 cups by the greatest amount. Now, remember, economists look at total cost as the total economic cost of producing a product, not the accounting cost, the economic cost. In other words, could you be using your resources in a different way to bring in more money? And what this is telling us is, if it's equal to 0 or positive, and we're earning a normal profit or a positive economic profit, then this is the best use of our resources to bring in the greatest amount of money. So long as economic profit is greater than or equal to 0, the firm should continue to operate. If economic profit were to dip below 0, and 0 of course is a normal profit, then Eli and Max would consider permanently closing their lemonade stand and finding a more lucrative business than the lemonade stand. Here is a video by Mr. Clifford, and it's practice using marginal revenue equal to marginal cost. So you should go to the ACDC Econ website and look for the video entitled MR equals MC practice and watch it. And that will give you some more practice understanding the profit maximizing rule. So here we're reminded again that short-run profit maximization is always the goal of every business, maximizing their profit. So they have to make the right output. Firms should continue to produce until the additional revenue from each new unit of output equals the additional cost. So if you assume the price is $10, should you produce if the additional cost of another unit is $5? Yes. If the additional cost is another $9? Yes. If the additional cost of another unit is $11? No, you should not. You only produce it if the money coming in is greater than the money going out. Marginal revenue greater than marginal cost. So here is the profit maximizing rule. And it's emphasized here because this is a rule that will apply for perfect competition, for monopoly, for oligopoly, and for monopolistic competition when we look at those market structures. So this is a rule that you absolutely must memorize, understand, and know how to use. The profit maximizing rule is where marginal revenue is equal to marginal cost. That's the quantity of output that a firm should produce to maximize its profits. Here is a practice activity that we will work on in class. And that's an answer to that. Here is another video that you can refer to on the ACDC Econ website. It is entitled Micro Unit 3, Question 9, Maximizing Profit, where MR equals MC video. So I would encourage you to go onto the website and watch that video. This is another activity on profit maximization that we will do in class. And then this is a summary of what we've looked at in this particular module. So you could pause the video now and review the summary on your own. And then that will get us into some practice questions that we will do in class. So this concludes our look at profit maximization in Module 53.